Research in the early part of the last century showed that the city of stars that we live in is not the only thing in the universe. The Milky Way is just one of billions of galaxies spread across billions of light years in space. In this section of Astronomy State of the Art, we'll look at galaxies, their properties and behaviors, and how they're distributed through a vast cosmos. We'll start with the Milky Way, our system of stars, 400 billion strong. We'll look at the evidence for dark matter, initially coming from what are called rotation curves of galaxies, or maps of the way the stars rotate in a disk as you move further out from the center. In the center of our galaxy, infrared and radio techniques have revealed a dense star cluster that hides another huge surprise, a supermassive black hole several million times the mass of the Sun. Exquisitely detailed observations have now revealed individual stars in orbit around this black hole, showing its mass with high degree of precision and venturing close to the event horizon of this extraordinary object. We'll talk about quasars and other active galaxies and what kind of extraordinary energetic phenomena occur in their nuclei. We'll look at the properties of galaxies in general, the different morphological types, spirals like our own Milky Way, giant ellipticals, and smaller irregular galaxies, and how we measure the distances to these galaxies and map out their positions in three-dimensional space. Also discovered early last century, the galaxies are all receding from us, a cosmic redshift that's an indication of the expanding universe. As surveys with large telescopes have grown to span hundreds of thousands or millions of galaxies, an exquisite filigree of large-scale structure is seen, on scales of hundreds of millions of light years. Galaxies are not randomly or uniformly distributed through space. They cluster into filaments and huge aggregations and superclusters with voids in between, almost bereft of luminous matter. Tracing back the cosmic expansion in time revealed a surprise 15 years ago, the detection of an accelerating universe in the last 5 billion years, not part of the normal Hubble expansion, and in fact, working in the opposite sense to gravity, which should slow down the expansion with cosmic time. This single observation has implicated dark energy, a component of the universe larger than dark matter, and many times larger than the normal matter that we're made of.